Hi everyone, so welcome back to my new video. So myself, I'm Santhosh Kumar R. So today in this video, I'm going to discuss about a small concept in control systems. So let us dive into the topic. So the topic is block diagram reduction technique. So what it is? So the block diagram reduction technique is a method used to simplify complex control systems. Okay, and it involves transforming a complex diagram into a simpler one while preserving the system's overall functionality. This technique helps in analyzing, designing control systems more effectively, and then it simplifies the representation of complex systems for better understanding, and then finally it helps in identifying key components and relationship within the system. And then so this is a simple diagram of control system. So there will be a input R of S, so that is Laplace transform of reference input, and G of S, that is gain, so that is nothing but equivalent forward path, and there will be a H of S, that is forward path, so that is nothing but a feedback path transfer function, and then C of S, that is Laplace transform of control output, and then finally E of S, that is Laplace transform of error signal. So the rules of block diagram reduction. So the first rule is associative rule. So it holds good for summing point which are directly connected to each other. So that is, there is no intermediate block between two summing points, or there is no takeoff points between the two summing points. So here it shows the block diagram of the associative rule. So which shows that there will be a summing point, and the first input is R1 and the second input is R2, and the signal is the negative, so we'll get R1 minus R2. So similarly here it is plus, so it will, the output will be like R1 minus R2 plus R3. And then next rule is blocks in series. So the transfer of function of blocks which are connected in series get multiplied with each other. So that is, if there is a takeoff or summing points between the blocks cannot be said they are in series. And here is the example for blocks in series. So here there are three blocks G1, G2, G3. They are in series. So we can finally write like the in the form of G1 into G2 into G3. Okay, and then the next tool is blocks in parallel. So the transfer function of blocks which are connected in parallel get added or subtracted according to the given signal with each other. So the direction of the signal through the blocks in parallel must be the same. So here there are three blocks G1, G2, G3 are in parallel. So we'll get add up. So three blocks will get add up. And then shifting a summing point before the block. So while shifting the summing point before the block, add a block having transfer function as reciprocal of transfer function of the block before summing point is to be shifted in series with all the signals at the summing point. And here is the a block diagram to show how the summing point shifts before the block, and then shifting the summing point after the block. So while shifting the summing point after the block, add a block having transfer function same as that of block after which the summing point is to be shifted in series with all the signals at the summing point. And here is a diagram or a figure which shows the summing point shifting after the block, and then shifting takeoff point before the block. So it means while shifting the takeoff point before the block, add a block having transfer function same as that of block behind which takeoff is to be shifted in series with all the signals take off from the takeoff point. So here is the diagram which shows the shifting of takeoff point before the block, and then shifting takeoff point after the block. So while shifting the takeoff point after the block, add the block in series with all the signals which are taking off that point having transfer function as reciprocal of transfer function of block behind which it takeoff point to be shifted. And here's the diagram which it shows the shifting of takeoff point after the block, and then removing the minor feedback. So this rule is a very important rule. So what does it mean? Like taking out the minor feedback loop in a control system involves eliminating a smaller loop that provides feedback within the larger system. This adjustment can help simplify the system and improve its overall function. So here is an example figure or diagram for removing a minor feedback. and then shifting takeoff point after summing point. So it means that moving the location where a signal is extracted to a different position after it has been combined with other signal. So here's the diagram to show how the takeoff point is shifted to the summing after summing point, and then shifting takeoff point before the summing point. So the shifting of the takeoff point before the summing point means changing the location where a signal is extracted before it is added to the other signal. So here is the example to show that how the shifting of takeoff point before summing point. And then the key rules or procedure to solve block diagram reduction are: so step one, reduce the blocks connected in series. So this is the important thing. So we have to find how many series connections are there, how many parallel connections are there. So we have to do according to that. And then step two is reduce the blocks connected in parallel. And step three is reduce minor internal feedback loop. And step four, as per as possible, try to shift takeoff points to the right and summing points to the left, unless until it is the requirement of the problem. Do not use rule number 9 and 10. So we have discussed the rule number 9 and 10 at the last. So we should not use those rules, and we have to shift the points of to the right, that is summing points to the left, and the takeoff point to the right. And then step 5, repeat the step 1 to step 4 till simple form is obtained. And step 6 is 5, using standard transfer function using simple closed loop system, obtain closed loop transfer function C of S by R of S of overall system. So, and then we'll solve a simple problem. So the problem is determine the transfer function C of S by R of S of the system shown in the below figure. So this is a figure which they have shown. So they have given two summing points and two blocks in series and two blocks in parallel. So you should do what means, like, if they are in series, you just multiply them, and if they are in parallel, you just add up them. So after doing the first step, you'll get the figure like this. And then after doing the minor loop, so reducing the minor loop, we'll get this one, G1 by G4 divided by 1 minus G1 into G4 into H1. And we had that parallel one, parallel one. So we got that G3 and G4. And then again minor loop, and you'll get the final equation as G1 into G4 into G2 plus G3 into 1 minus G1 G4 H1 divided by 1 minus G1 by G4 into G2 plus G3 divided by 1 minus G1 G4 into H1 into H2. So this is about the topic and the problem. So if you like the video, please do like. Thank you for watching the video.